So now we'll go for one sample problem so that we'll get better understanding how to solve the questions. Okay, so solution. Here what I'll do is first write the given differential equation d cube y by dx cube minus 2 into d square y by dx square, okay, plus 4 into dy by dx minus 8y is equal to 0. Okay, so it implies, I'll write this in terms of operator form. Okay, so d cube, d third order derivative can be written as d cube, okay, minus second order derivative can be written as d square, so you can write it as 2d square plus 4d, okay, minus 8 into y, okay, so this one is equal to 0. So this differential equation have converted in operator form, okay, this is operator form. Okay, so you can write where d is nothing but d by dx. Next, d square is nothing but d square by dx square. Next, d cube is nothing but third order derivative, that means d cube by dx cube. Okay. Now, what I will do is take it as equation 1. Okay. So the auxiliary equation of equation 1 is nothing but replace d by m. Okay. So what happens? You'll get m cube minus 2m square plus 4m minus 8 equal to 0. This is 4m. Okay. Now what I'll do is I'll find the roots for m. Okay. So what happens? How much you'll get the roots for m? So in the first two terms I can take m common. What you'll get? M minus 2 I'll get. Next, in the second term I'll take 4 common. You'll get m minus 2 equal to 0. So implies m minus 2 you take common. How much you'll get? M plus 4 is equal
M
to
square.
0. Huh?
M square
Here,
plus
here m square. M square. Sorry, here m minus
m square plus
m square I have taken common, correct. So m square plus 4 will get. Okay. Now implies m equal to 2 will get. Similarly, m square equal to minus 4 I will get. Okay. So implies m equal to 2, comma, m equal to plus or minus 2. Sorry. Plus or minus root minus 4. So this is nothing but plus or minus 2i. Fine. So total 3 solutions I got. One is real root and one more is complex pair. So the roots are real and complex pair. Okay, whenever the roots are real and complex pair, first write the solution like this. You can write, therefore, the complementary solution is okay. So the complementary solution will be denoted as YC is equal to, first root is m2, m equal to 2, right? So c1 e power 2x. Okay, so first write c1 e power mx. So first m is 2, so I have written 2x. Similarly, plus here this can be written as 0 plus or minus e power, sorry, 0 plus or minus 2i. So that means real part of m is nothing but 0. Okay, imaginary part is 2. So write according to this solution. Okay, so what happens? E power px. So e power p is nothing but 0 here. So 0x into c1 cos qx. Q is nothing but 2 here. So I'll get 2x plus c2 sin 2x. So therefore your solution will become how much? c1 e power 2x. So here c1 already you have used. So you can write it as c2 c3. Okay. So plus e power 0 is 1. So c2 cos 2x plus c3 sin 2x. Fine. Getting? Yes, are you getting? Yes, we'll go for next one, so that for you will get better understanding on it. Let's check this. In the same way, we'll try to solve this equation. So solution. Okay. So my question is d cube y by dx cube plus 6d square y by dx square plus 11 dy by dx plus 6y equal to 0. Okay, so implies first convert it in terms of operator form. So that means d cube y, or I can write it as at the end d cube plus 6d square plus 11d plus 6 into y you can write. Okay, so this one is equal to 0 you got. Okay, so this is operator form. Okay, now therefore the auxiliary equation for above equation is convert this in terms of m. So that means m cube plus 6m square plus 11m plus 6. Okay, is equal to 0. Now how will you solve this cubic equation? Every time we can't solve the equation like this. This is like sometimes you'll get like this in an easy way. You can take common and you can do, but it won't be all the times. So here we can't solve in the previous method. So how to apply this? Okay. I think you have solved this kind of equations in your PUC. There is something called synthetic division. Have you remembered it? Synthetic division of a quadratic cubic equation. How to do that? By synthetic division. Okay, so what I'll do is, first I'll write the quotients of all the things. Okay, 1, okay, 6, 11, 6 is there. In an order wise I have taken. Okay, m cube, m square quotient, m quotient and constant. Okay, now write the equation like this. First term you put 0. First we have to search for first root. Okay, okay, which should satisfy this equation by trial and error method. Okay, so we have to substitute plus 1, minus 1, plus 2, minus 2, similarly plus 3, minus 3. Among these three values only we'll get the solution most of the times. Okay. Suppose if I substitute m equal to 1, what happens? All are positive terms, you won't get anything else. Okay. Suppose if I take m equal to minus 1, my trial and error I am checking here. So if I take m equal to minus 1, what happens? M cube is minus 1 cube, it is 1, minus 1, plus minus 1 square is plus 1, so 6 minus 11 plus 6. Okay, so what happens? 6 plus 6, 12, minus 1 minus 11. So it is minus 12. So you are getting 0. So it is satisfying this equation. Okay, so we will get m equal to minus 1 is the one solution. Okay, so this minus 1 what I will do is I will keep it here. So this solution will get by trial and error method. Clear? So you have to check plus 1, minus 1, plus 2, minus 2, plus half, minus half. Similarly, plus 3, minus 3. Among these solutions only, you will get the solutions for most of the equations. Okay. So after putting minus 1 here, first add this one. How much you will get? 1 plus 0. You get 1. Okay, after adding this, multiply with this quotient. What happens? Minus 1 into 1. You'll get minus 1. Next add it. You'll get 5. Okay, again multiply with minus 1. So you'll get minus 5 here. Again add it. You'll get 6. Multiply with minus. You'll get minus 6. So if you add these two, having opposite symbols, you'll get 0. So after getting 0, you have to close this solution. Okay, so once you got 0, you'll get remaining terms here. These are the quotients of quadratic equation. Okay, so first solution, I got it as minus 1. Next, Using this minus 1, I have converted the cubic equation in terms of quadratic equation. Okay, so how to write this means, what is the first term in quadratic equation? Square term. So m square, the quotient should be 1. Next, here m, the quotient must be 5. Next plus constant, that is 6, is equal to 0. So in this way you have to rewrite this equation. Now you can find the solution of this equation to find the remaining roots. Okay, so in the first term, if I take how to solve this, either you can use minus b plus or minus root b square minus 4ac. That formula you can use, or normal method also you can use. So 1 into 6. So factors of 6, which we should get 5. So that means I can write this equation as m square plus 3m plus 2m plus 6 equal to 0. So take m common, m plus 3 will get, plus 2 common, m plus 3 will get. If you take m plus 3 common again, into m plus 2 equal to 0. Okay. So therefore the roots for m are minus 1 you'll get, m equal to minus 3 you'll get, similarly m equal to minus 2 we got. So therefore the roots are real and distinct. Okay, so instead of writing all as m's, I'll write m1 equal to this one, m2 equal to 3, sorry, minus 3, m3 equal to minus 2. Okay, so therefore the complementary solution is the complementary solution of given differential equation is so yc is equal to c1 e power m1x plus c2 e power m2x plus c3 e power m3x. So yc equal to how much? C1 e power m1x, m1 value is minus x. So e power minus x plus c2 e power, in the place of m2 minus 3 is there. So minus 3x plus c3 e power minus 2x. So this is the complementary solution of given differential equation. Fine?
Sir,
Yes?
can you explain synthetic division once again?
Synthetic division is nothing but, first you have to guess the solution for a cubic equation. Okay, how will you guess? Means the solution will be maximum in between minus 1 or 1, plus 2 or minus 2, plus 3 or minus 3. Suppose if all these 6 roots you have solved, till you are not getting, so then go for 1 by 2 or minus 1 by 2. Among these 8 solutions only, most of the equations will be solved. Okay, so once you got this equation as 0 for any one of these roots, okay, so write that root as in the left hand side here. Okay, so now what I'll do is, I have written the quotients of given equation here. M cube quotient is 1, m square quotient is 6, 11, m quotient is 11, and constant term is 6. So next what I did, first I put 0 and I have added. Okay, so if you add it, how much you'll get? 1. Okay, now multiply this cofactor into this term. how much you'll get? 1 minus 1 into 1. So you'll get minus 1 here. Similarly, add it. Second term also you add it. So you'll get 5. So 5 multiply with factor. So you'll get minus 5 here.
Understood,
Then
sir.
add it. Okay, like that.
Sir,
So finally you should get 0. Yes.
sir, for the cubic equation, you have given the set of solutions like -1, 1,
Yes, yes,
minus
yes.
2, and 2.
Ah.
Is it applicable for all degree of equations or only for cubic, sir?
All kind. Like
So even if it
suppose
is
if
a
you are getting more than 3 also.
So if it is a quadratic equation or a equation with degree 5, even then it is going to be the same set of solutions, or are there more possibilities that time?
For quadratic equation you can find directly now. Like you can put -1 plus or minus minus b plus or minus, you can use that formula.
For
Okay,
a
suppose if it is more than 5 and the more than 3, so then also we'll try these solutions. Okay.
Okay, sir.
Okay, then also we'll try these solutions. Still we are not getting means we'll go up to 5. Okay, so it will increase. Suppose if it is fifth degree equation means it will increase. Up to plus 5 or minus 5 we'll check.
Okay, sir.
For
Understood.
fifth degree.
Yes, sir.
So most of the questions they won't be having like this.
Excuse me, sir.
Yes, yes.
So when we use those solutions, is it
Ah.
that the equation should become 0?
If it is satisfying that equation, this should become 0.
Okay.
So that means if we are not getting 0 means this selection is wrong.
Now we got -1. So there we got the answer as -12, right?
Where?
When we substituted -1 in the equation.
How much will get? Substitute it. -1 cube. It is -1 plus 6 into -1 square. It is plus 6. Next minus 11 you'll get. 11 into -1 you'll get -11 plus 6 equal to how much you'll get? 0 we are getting. So that kind of solution only we are selecting here.
Okay, sir.
Fine.
Yes.
Is getting? You try one more equation so that you'll get better clarity now. So for this also you apply synthetic division. So here directly he has given in terms of operator form. So d cube minus 3d square, minus 3d plus 2 into y equal to 0. So auxiliary equation is what happens? M cube minus 3m plus 2 equal to 0. Okay. Now for this I have to check initial solution. Okay. How will you get into initial solution? What I said, substitute plus 1 or minus 1. So if I substitute plus 1, what happens? 1 cube 1 minus 3 plus 2. We are getting 0. Okay. So directly for plus 1, we are getting 0. So after checking this root, what I have to do is, first write the quotients of all these in order wise. M cube quotient is 1. M square quotient is 0. We don't have term, so you have to put 0 here. Next, M quotient is minus 3. Next, constant term is 2. So, write like this. We got M equal to plus 1. So, write that 1 here. First put 0, add it, you'll get 1, multiply it, 1, add it, 1, multiply with this, you'll get 1. If you add, you'll get minus 2, multiply with 1, so you'll get minus 2, finally you'll get 0. Definitely you should get 0 here. if your solution is correct. Okay, so now what I have done is I have rewritten this equation in terms of my quadratic equation. So therefore, m1 we got it as 1. Next, for finding m2 and m3, I will get quadratic equation. How to write quadratic equation means first write m square, quotient should be first one. Next, m term, quotient should be this number. So 1m minus 2 equal to 0. So we got m square plus m minus 2. So what are the factors for this? So we need to find that. If you multiply m square quotient and constant term, you'll get 2. Factors for 2 which gives the number as 1. So that you have to select. So this will be equal to m square 2, we can get it as plus 2m minus n minus 2 equal to 0. So if you take m common, m plus 2 will get. If you take minus 1 common, m plus 2 will get equal to 0, implies m plus 2 into m minus 1 equal to 0. So implies m equal to minus 2 will get, m equal to plus 1 we got. Okay. Similarly, now rewrite all the roots at once first. Implies m1 equal to, you can write this as m2, m3. Okay, m1 we got 1 already. Next m3 also we got 1. So m1 equal to m3 equal to 1. Similarly, m2 we got it as minus 2. Okay, now you need to apply the solution for it. So therefore, the complementary solution is how to write? YC is equal to, first write equal roots. For equal roots, what is the way? You need to write C1 plus C2 into X. Okay, so into e power m1x or m3x you have to write. So m1x is nothing but 1x. So I can write 1x here. Plus this is distinct root other than this. So I have to write C3 e power minus 2x. Getting how to write the solution? When you got equal roots, you have to write C1 plus C2. How many times it has repeated? That many times you have to write. Okay. So into e power that root into x plus C3 into distinct root you have to write. E power that distinct root. Fine. Getting?
Yes, sir.
Now try for this problem. You only do the synthetic division and check what solution you get it as 0. So here 2 roots you have to apply because synthetic division can be applied. We have to convert this 4th degree equation into 2nd degree term. So this time we have to verify for 2 roots by trial and error method. So d power 4 minus 5d square is there plus 4 equal to, into y equal to 0. So the auxiliary equation is how much? M power 4 minus 5m square plus 4 equal to 0. So how to find the solution for this? So by writing it in synthetic division form. M power 4 quotient is 1. M cube quotient is not there, so 0. M square quotient minus 5. M quotient is also not there, 0. Next constant term. 0 you put. First you need to verify with some solutions. So basic solutions you find. Plus 1 if you substitute, what happens? 1 power 4, 1. So you'll get 5. So it is satisfying. So 1 power 4 minus 5 into 1 square plus 4 equal to 0. So 1 plus 4 it is 5 minus 5 it is 0. So one root it is satisfying. So apply synthetic division with this root. What happens? 1. So 1 into 1 you'll get 1. So add it 1 you'll get 1. Next minus 4 multiply with this you'll get minus 4 again. Add it minus 4 again. Multiply it minus 4 again 0. Okay. Next. So this is a cubic equation. So again for cubic equation one more error we have to do. The one more solution you need to find. So 1 is already over. Okay. So next check with one more number, which should finally give us zero at the end. Okay. So again put 0. So write this equation separately. We got it as m cube plus m square minus 4m minus 4. So this is this equation. Okay. So if you substitute minus 1 here, what happens? 1 is already used. Okay. So what happens? Minus 1 if you put, you'll get minus 1 plus 1 plus 4 minus 4. Okay. So we got it as minus 1 is the another root. So I have substituted minus 1 in the equation. So minus 1 I have written here. If you add it, how much you'll get? 1. 1 into minus 1, you got minus 1. So you'll get 0. Next 0 minus 4. Minus 4 into minus 1, you'll get plus 4. So minus 4 plus 4, 0. Okay. So you got like this. So implies what are the roots? M equal to 1, m equal to minus 1. Next write this is in terms of quadratic equation. So m square plus m term into 0. So it is 0 minus 4 equal to 0. So this is m1, this is m2, m3 and m4 will get by this. So implies m3 equal to m4 is equal to, how to find the solution for this? M square is equal to 4. Implies m equal to plus or minus 2 will get. Okay. So therefore the roots are real and distinct. So therefore m1 equal to 1, m2 equal to minus 1, m3 is equal to 2, m4 equal to minus 2. Okay. So therefore the complementary solution is how much? Yc is equal to, all are distinct, all are different numbers. So I can write C1 e power m1x plus C2 e power m2x plus C3 e power m3x plus C4 e power m4x. So yc is equal to how much you'll get? C1 e power m1 is 1x plus C2 e power minus x plus C3 e power 2x plus C4 e power minus 2x. So in this way you need to write the solution.